All right. Starting in to lesson two, if you watched my introduction in lesson one, I talked about the application architecture. And we're going to just jump right into lesson two. And what I want to do in this video series is show you me going through the process and you just able to see how it looks because not sometimes just explaining it or reading, you don't get to see the struggles that people come across as they begin to do this stuff, especially when you're learning and you don't really know how to troubleshoot issues that arise as you're doing this stuff. I'm not going to really, I haven't, I've done my preparation as far as like getting this document together, but I'm not really going to go into like getting a whole scripted and outline and stuff. I just gonna do it raw, and you're gonna watch, and that way we learn together, and you see the real thing. It's not some canned scripted thing that's going on. You're actually learning how to become a computer application developer. Um, so here in lesson two is a we're going to go completely with the database and just set up a database. And in this database, you'll be able to, we're going to create a contact list like I've shown here. And I went into this a little bit in lesson one. We'll get way more into it here. But here we've got an example of the data that we might be wanting to store as we're creating a contact list. Think of it like an address book or a list of your friends or whatever. We want, people's information, their name, what street they live on, the city, the state, the zip, country, phone. Now, as you're developing this, it's critical that each record that you store in your data has a unique identifying um, uh, bit of data with it so that you can quickly and easily access that particular record if you have that unique identifying data and you don't have to search the entire database all the time to try to find information about that. If we didn't know that Martha was on in ID number 2, then we'd have to go off of Martha based on like her name, what we typed for her street or her city, state, zip. We'd have to start asking the end user all this data and try to match it up. And what if we got multiple Marthas, or we type the street with a lowercase c instead of uppercase c, or not a space, like all these different factors, and trying to search for that data, we'd lose it. We'd never be able to get to it. So designing your data with unique identifying columns for each table is critical. And then what you can start doing is linking your data between columns with that unique identifying data. Let's say, for instance, we wanted to have a table of just addresses. And in this table, maybe we'd have just the user table, and we'd have a separate table with their address. So maybe we'd cut out street, city, zip, and country, and take that over to a second table. Let me open up my Excel again so you can see here. So we'll say user, and here we're going to have ID, name, and phone. Okay. And maybe we want to have another column like let's add last name, Now I'm just demoing this in Excel. We'll get into actually doing this in the database here in a second, but I wanted to just kind of explain the concept here. So we have 1, 2, 3, 4, right? And let's just take our data here. Oh, I can't. We'll say Fred S, Martha N, John B, Paul P. And whatever their phone number. Okay, so we broke out the address, right? So let's create a new table, new spreadsheet here. We'll call it address for now. And we're gonna say ID for the address ID now, but we still need to know which user this address belongs to. So we could put here column header user ID, and then here we'd have street 1, city, state, zip, country, maybe even, oops, back here, get rid of that. Maybe we want this to be county, and this one country. And then here you'd have these IDs would be unique to the addresses, so there might be duplicates. And then here you'd also, let's say this was 432, so those would link up with, just say like that. So Fred would actually be linked up with the 4th address record that's in the database. I don't know if I'm explaining that well, but those are so this is what you'd call a foreign key, which means it's foreign to the address, and it's a key to the user table. And then this address also has a key for its record there. And as you design this out, what you want to do is start breaking out. You want to organize your data in like data. Like you want to keep addresses together. If, for instance, you're putting your users together, but maybe you have different user types, right? You have some users are actual application users who are logged into the system, and some users are contacts that those users have entered as people that they know and people they want to keep track of, but they've never actually logged into the system and aren't whatever. You might have a different type column here, and that type would help you to split out that data so that you'd go to other tables to determine where to access more information about them. The other thing about, like, as you're building your database structure, you don't want to have multi-value fields, which in most databases is not possible because it's a really bad idea. But say they had multiple phone numbers, so you have 1, 2, 3, like separated by a comma separated list. That becomes impossible to search to find if you need to access their data in most relational databases. That's just a really bad idea. So that's a case where you'd want to break out and create another table, maybe in this case, because we're using this as an example, phone, and then we'd have ID again, and here we'd have user ID, and Here we have phone number. And maybe you want to keep track of their carrier now too. I don't know. Something to give it a little more data than that. But then we'd come here, we'd get rid of the phone column in this case. So then you just have user and type. So then maybe this is a contact, and this Martha is an application user. So this is a more complex example that I'm going through right here than what we're going to do in our application. But I wanted to kind of give you a high level view of how to organize your data, why you're using a database in the first place, and how to structure that data in a way that will be easily accessible for you in the long run. Now, one thing I've left off here, which we're gonna cover right now, but if you're building a SaaS application, SaaS meaning that you're gonna use this application for here, I'm gonna open up this, and so we can just. You're going to basically use this application and resell it to multiple companies, and companies are going to use your application for. So you're basically going to be a reseller of the same application, and you're going to deploy it, host it, launch it, and keep it up and running for them. But they get to reuse your logic. Sorry, I spelled that wrong. Let's read this real quick. A method of software delivery and licensing in which the software is accessed online via a subscription rather than bought and installed on the individual computers. So we used to basically buy programs, install them. But a lot of times now we go to companies like Salesforce and Zendesk, we go to these companies and we don't even ever install their program. We sign up and we start using it. Facebook even is an example of that. We're not paying Facebook and we're not their customer, but we sign up and we use their thing, and we never install the product on our machine unless you go and get the app or whatever. Let's not overthink it. They're just, this is what Salesforce is, and Salesforce is a huge corporation that most companies in the United States are using in some regard, a lot of companies, and they never install any program on their own computers to use it. They go to the web. Okay, so, sorry. If you're designing a database with a SaaS model, which you might want to, and it'd be good, you always start by structuring your data with a company ID. And there's multiple ways to do this, and I don't want to argue with other developers about how they do this or whatever, or if I'm setting it up right. This is a simple beginning tutorial, but in the just kind of the basic concept is you want to have the company ID wherever that is, and you obviously, since we add a company ID, we got to have a company for that ID to reference. Name. So anyways, we put 1 and 3 in there. So maybe company 1 is X company. Company 2 is comp Y. All right. Okay, so the reason that we structure our data in this way is so that if John and Paul belong to a different company that's using this program, um, but Fred and Martha belong to a different company, we never want John and Paul to show up in company one's data on accident. They would find that very problematic, and just they would be very upset if their data was being accessed by a potential competitor. Okay, so we want to separate this data out and make sure that we're always using the company ID and putting the company ID in all the data structure so that you never have an instance where you accidentally are showing uh, different people's data, different companies' data across a thing. This is if you're basically developing a product like Salesforce, which is used by many companies, but you have many users in those different companies all using this and accessing the data. It's a good way to start, because if you didn't start this way and didn't add the company ID in your application, then you can't go back and add it, especially after you've got a bunch of users. You can, but it will be a huge pain in the neck for you. Okay, so let's get back to kind of this. And I've gone way more into the design and structure of a database because I want these lessons to be more than just the high level and just really quickly get it done. But I want to give you some groundwork to go off of, and some things to play with. Now, when you're building your database out, and we're still talking SQL databases, relational databases, I'm not getting into object databases or other kind of databases. You can get some other tutorials on those, or maybe I'll create a video sometime going over a NoSQL database. But for now, we're just talking SQL databases. And what is SQL? Since we're looking here on Google, and we'll just pull this up. What is meant by SQL? SQL stands for Structured Query Language. SQL lets you access and manipulate databases. SQL became the standard of American National Standards Institute in 1986. That's a long time ago. And the International Organization for Standards in 1987. So SQL is a language that you'll need to learn, and it's actually a really cool language, but also, yeah, as you get into software development and think that you're gonna or become a developer or whatever, you'll be online all the time and looking up all sorts of things to add to your skill set. So you're not gonna you're not gonna be like a single language developer. You're gonna be a multi-language developer and figure out how to use multiple languages to accomplish the jobs that you need. For starters, we're gonna have SQL as a language in our tool belt. But we're also, by the end of this course, we're going to have a Java middle layer and a Angular JavaScript front end layer. So you're going to learn 3 different languages right off the bat. And, a lot of people who are outside of computer programming will be like, oh man, you got to learn multiple languages and that's really hard. It's not like languages as in like speaking languages. It's these are tools that have very specific jobs that help you accomplish what you need to do. In fact, right here, This is W3 Schools. This is an excellent website for referencing all sorts of languages. And right here, they have it right at the top. A lot of their high level ones: HTML, CSS, JavaScript, SQL, Python, Java, PHP, Bootstrap. How to is not a language. W3 CSS, that's a new CSS standard. Then you got C, C++, C Sharp, React. I don't know what R is, I'm going to be honest. jQuery and Django. I could look up what R is. I don't really care. I know a lot of other languages. And there'll be thousands of languages, and new languages will come up, and you'll just adapt to most of them. They're mostly structured the same in a lot of ways, with minor nuances and changes to help you accomplish what you need to do. So you just got to find what really look at this. I found a typo in my thing. I didn't laterally. Oh, it's a PDF. I can't change it. Yeah. So, okay, let's get into this. So first things first is you've got to get a terminal that you like. I don't know how well this is showing up on my thing, but I'm gonna probably zoom in a bit to make this a little bit better for you to see. If I can figure out how to zoom. Command Shift O. Whoa, what the? Might not be what I wanted. Huh. What is it? Oh, that's not really what I wanted. View, make text bigger. Okay, so Command plus. Okay, let's make this big enough. Now, first things first, we haven't got into this yet, but I'm assuming you're starting completely from scratch. You haven't installed anything on your computer. I'm gonna close this too because I don't like this in the background. So you need to find a way or have a way for your computer, depending on your Windows or Mac. I'm on a Mac, which means I'm not on Windows. So you'll have to go through some of the struggle if you're on Windows on your own, but that's part of the journey, part of the fun, right? But on a Mac, there are these, well, across the web and in the industry, there's package managers now that basically will help you install and use programs. This was a concept originally delivered by Linux operating systems, where you could, instead of going to the web and downloading programs, you could use a package manager. So right here we got package manager for Mac. So that's a cool thing. But or I said Mac and it's Windows. You can find a package manager for your operating system and start to learn and see how to use it and whatever. A package manager, what it does is it holds software application installations within it, and then it helps you manage and keep those software installations up to date. So on Mac, a lot of people use Homebrew. Brew is a really good package manager for Mac, and so that's what I've used. So let's just look here and see what I've got installed. You'll obviously, especially if you're new to these things, you'll have to come here and learn what you can do with the application, with the brew application, and what the commands are in order to figure out how to use it. I did brew list. It says list all installed formulas. So here we go. These are all the things I've installed with brew. And MySQL is one. But if you were to be starting here from scratch, like I promised, you'd do brew install MySQL. You'd hit that and run that, and then you'd have MySQL. I'm going to do brew update MySQL just to make sure it's up to date. I'm also going to look this up and make sure that this is the right thing I want to do. Yeah, so fetch the newest version of homebrew formula. Whatever. Let's see what that is. This command updates brew itself and does not take... okay, so there, I screwed up. That's why I'm doing this here with you. Show you that, not everyone knows everything and does it completely right the first time. All right, so MySQL is already installed. Okay, so yeah. Okay, so now I got access denied, right? This is gonna be tricky because I don't know if I remember my password. Let's see here. Let's see if I put it in the document. So you can also, if you don't want to use a package manager, we're using MySQL database. So you can go to the web and you can do MySQL download. And go to the downloads page, pick the right thing for your operating system, and run through their installer and let it install. See, that's what I said right here. I said Microsoft SQL. I was going to do Microsoft SQL, but I switched to MySQL because of licensing and other stuff. I just want to give you a tool that you can use without having to pay for whatever and just kind of get going on a trial. Sorry, I'm reading through this to figure out. Oh, geez, I don't remember my SQL password. See if 1Password has it. All right, I'm back. Okay, so what I decided to do is come here and we'll go to the MySQL page. We'll talk about the MySQL yeah, you know what? Let's just do this. And we'll go brew, uninstall, MySQL. Okay, so it uninstalled it. Now we'll start from scratch here. Brew install MySQL. Oh, we just got rid of it so that we can show you how to do it from the beginning. So Brew's nice because it pulls in dependencies and other stuff that might be needed. Oh my goodness. This is terrible. Oh, that looks horrible. Alright, I'm gonna fix this, guys. Wow. Why is it so bad? Oh, I know why. There's no light in the room. That helps that thing figure out what it's doing. Okay, sorry. Sorry, little technical adjustments there. Okay, so it says right here that it installed it, and you can have a restart service going on with Brew. So if you want it to start up every time you log in or your database to be running, it'll be there. And let's do this. Okay, so now we are logged in as root to MySQL, and we're right there. So now we're on the command line for the database. So let's see if we can list the tables that are here. Okay, so what you're going to want to do is you do want to find yourself a good database client. Let's look here what we've got here. Remember how we talked about clients in the first lesson? Well, here's a case where we need a client to use the database because, I don't know what I'm typing here. MySQL client for Mac. So client is a UI that we can use to access the database. IntelliJ SQL client. Alright, so let's go here. Data grid, that's what I want. Oh, it's a 30-day trial. Yeah, I don't want that. Let's see here. MySQL client for Mac, free download. Okay, I don't want to skip all the ads. Let's just get this one. No, I'm not going to get that one because I don't trust it. And since MySQL has been taken over by Oracle, there's not a great thing here. There we go. What's heat wave? That looks like a lot more than what I want to be doing. MySQL Standard Edition. Data sheet. Well, I use SQL Developer all the time. This is a decent client. I'm gonna pull this up in SQL Developer and log in there. Let's look up MySQL, where you have to figure out how to get logged in. MySQL default port. So it's going to be running on some port. Okay. So I've got these connections, don't worry about those. We're going to add a new connection. There we go. We'll call it MySQL. Username root. Leave the password blank. Localhost 336. SID. I don't know. Leave that blank. JDBC URL. I'm going to go right here, do this. So let's get rid of this. Right. Sorry, I'm way off on a tangent here. We're stuck on authentication because we went off track here. So I'm gonna just go with this for now. So it already exists. let's go find out how to update password for root. Or first of all, list users. Okay. So this is SQL right here. I don't know the names of the tables, so oh my goodness. Yeah, that's not good. This is why we need to get connected with the thing, but with the client. So here's the table structure for the users. It has a column called host, users, selected privileges, insert privileges, update privilege, all these different privileges. So we can simplify this down by saying, let's just select the host and the username and password from this table. Oh, gotta have the semicolon. Host, user, password. I don't know if that's in there. From user, it says the column password isn't in the list, which probably is pretty true. So here we got our users right here. We got root, we got Spring user. This is the one I created. So even though I uninstalled it, it turns out that it didn't work to uninstall it. So I'll just go from here, grab this, grab that, change this to proj 1, and test this. Database type is not Oracle. Oh, don't tell me I can only use. Let's double check something here. Yeah, it's using Oracle. So we're back to the client issue. I think we need a client, so let me get a MySQL client here. Okay. This obviously is going to list a bunch. We'll go here, SQL Pro. Unzip that and pull this up. We'll go with the free trial for now. I don't. What? password. I wonder if I can do root, no password. Let's just try that. Okay. All right. So here we are. We actually got logged in. We're looking at the data in this database, and I did, when I set up the connection, I set no password, and then when it prompted for a password, I didn't put anything. So I'm logged in as root, which is the default user that was set up when I installed it with Brew. Okay. Now, let me just say this for all the haters. Obviously, when you are working on your thing and setting up your thing, starting your thing, you want to change your password right away. So let's just do that right now. So you can log in with your user right there, right? Here's what we want to do. We want to use the language syntax of SQL and say alter user root at localhost. This at localhost is similar to like an email address, where it's telling us what server is it that we're gonna change the password on, and I'm not gonna use this cool password. I'm gonna use this cool password, but that's just so that next time I try this and try to get in, I can actually get in. You can I'll do it this way, actually. So I'm going to do a new login. This is my password manager. I'm going to say root at localhost, and this, I'm going to create a password for it. Now you see my password, but hopefully you don't hack my computer and get access to that. But now I'm from here. I've used the password manager. I highly recommend using password manager. 1Password's great. I can access it on all my devices, all my computers across everywhere, and I can get access to all the things I've saved. You can create, when you generate a password, you can create passwords that are so long, like 20 characters, add symbols. You know, these passwords will take computers trying to brute force your account, will take them years to brute force and figure out what your password are. Your typical password can be hacked in less than an hour. So using password manager is super important and really good, and keep you safe. So I'm going to come here, back to here. We're going to change our root password to what we just saved in 1Password. Notice how I started first with 1Password, because the reason I did that is because I want 1Password to generate it, and I want it to stay within the 1Password system, so that I don't put it in, try it, and then see if it works and get that failure, all that stuff. Okay, so now for all those haters, I changed my password, and I told you to set your password. I'm going to change my privileges here. And it says to exit. Oh, we can exit. Let me copy this one more time. Okay, so now we got to do this, and we got to do P, paste in our password. Now we're back in. Okay, so I'm glad I struggled with that. I'm sorry you had to watch it, but guess what? When you're getting yours set up, um, this security is going to be the struggle, not all the other things, and not getting things set up correctly and getting things set up the way you want to see them. That's going to be the tough part. Okay, so here I'm going to go through. You already seen that. Where's my document? Okay, we're finally here. Now I'm going to create a new database. You want to run create database project. Okay? But you can see here in mine, I've already got that database. I don't want to confuse you with other things. So hold on one second here. Okay, no tables in here. Okay, I'm gonna actually drop that so that we're going through the same thing. Let's refresh. Now you can see project's gone. So I'm going to rerun that command, create project, refresh. There it is. You can do all that stuff from here if you want to. I think it's good for you to learn this syntax though, this language syntax. Now I'm going to switch my local client to be using that project database that I just created, so that when I run these other commands, as I run these other commands, it will use this database and not some other database. Okay, so I probably didn't explain that well. When you're in MySQL, think of MySQL as like the ecosystem. It can house multiple databases, and then there's also schemas. Schemas are a subset of folder under the database, and then you've got tables, and then a bunch of other type of objects, indexes and other things that might relate to the table. But so when I say use project, that's saying now that I've got the project database, when I run a command, stay within the project database. Don't go outside to other databases that I might have in the MySQL ecosystem. Okay. So now I'm going to create a schema called proj1. Different databases act differently. It looks like MySQL considers databases and schemas as the same type of thing, where Oracle has schemas, which are folders kind of under the database. Sorry about that loud bang. Okay. So now, oh, I didn't like that. Okay, let's cancel out of that or whatever. I don't know. Okay. So now we've got to create a table to store our data in for our contacts list. Okay. If you like to use the UI way, you can do the UI way. You just come here, say new table, give a name, list all this stuff. Let's go with the defaults. Honestly, you can look up what it means later. Or you can come here, take this, and this has to be on one line. So I'm going to make it on one line and fix it up. I've just opened up, sorry, I didn't explain that, but I've opened up a text editor here and I'm fixing this up in the text editor. Now I want it to end up in our database called project right there, right? So that's where I put it. Now, so I'll explain the create table syntax a little bit. You've got create table, then you've got to list the table name that you're going to create. So I've put the database that I want it to be in, and then the table name that I want. First, I always define an ID column for that table, like we talked about previously. And then you have to specify the type of data that table is going to hold, or that cell for the ID is going to hold. I'll review this in a second, but then I've got this key word here after the type. So it goes ID type, and let's just look this up actually online too, because I want you to really get familiar with using, let's go to W3 Schools, and using the reference for all this stuff. In fact, it looks right there, there's a MySQL reference. So here's a MySQL reference. Okay, cool. So MySQL select. But what we were talking about was creating tables, right? So create database, create table. Okay, so it's fairly simple. We create the table, column, data type, column, data type, column, data type. Now, let's talk about data types. Data types are the type of data that you're going to store in that field. There are many different types of data types, and you want it to be fairly close to accurate of the right representation of the data that you're going to use. In their example here, they have a person ID, which is their ID column, and an int, and then last name, first name, address, city. Those are varchars. They're gonna, and they've specified 255. So varchar is a variable character. It's like a string database, or a string column. It's gonna hold multiple different types of characters, numbers, letters, symbols, and it can hold 255 of those. In this case, they could specify varchar 2 and only hold 2 characters. The reason why that matters so much is because if we go back to Excel, and we had, multiple columns here, and let's say one of our columns was zip code, right? And we were only ever going to store a 5-digit zip code. Then we'd probably want to set this field up as varchar 5 so that it didn't go any bigger than 5 digits. And then that way it would be only 5 characters, because what happens on your hard drive when you specify the column, if we said varchar 255 for a column that we knew would only ever hold 5 characters, then 250 bytes of data are used up for every single record that you store in your database. that is completely unused and a waste. So that, as you can see, like holding millions of records, wasting 250 bytes each time, might seem like it adds up quick, I guess, is my point. And so you don't want to architect yourself into a corner by being too strict on the data type and how much data you can store there, because in my example that I just showed you, sorry, a zip code at only 5 is a really bad idea. You want to be able to expand to be able to hold the 5 and then 4, plus there might be some other rules for other countries. As you grow into other countries, you want that to hold enough that it works for all the countries as well. And so that's why you might be like, well, all our zip codes around here are all numbers, so I'm just going to use an int as a data type. And that's probably a bad idea too, because you get into other countries and you need to be able to store letters. So, but that being said, a varchar 255 for zip code is probably overkill. It's a full sentence, and we don't need that much. So you want to think about it, and you want to adjust for the right size. Maybe varchar 15 is a good size for a zip code. I don't think that there's any country that has more than 15. We're not limited to the 5. It holds letters and characters, which is great for multiple countries. So I think, you just want to do your research, figure those things out beforehand. Next thing here, I hate these ads. They assume because I'm a guy, that's what I'm gonna do, and they feed those ads to me. I should use Brave as a different browser so that those don't come up. But they're here. Okay, so we're talking data types. We covered varchar. There's also Boolean, bool and Boolean. These are the same in MySQL. There's small int, medium int, int. These are all just, like I was talking about, different sizes of data. So if you're going to do a small int, it's basically a number positive or negative, up to 132,000, then you can, if you know that number's not going to be more than 32,000, then you use a small int when you're creating the table, or a tiny int. Tiny int is only up to 127. So if you're going to have for sure it's going to be very small data, you can use that. Let's talk about signed and unsigned. That basically means, are you going to go below 0, or are you not going to go below 0? If you're not going to go below 0, it's always going to be positive or 0, then you want to say unsigned, and you can go up to 255 in that case. If you know it's going to go negative, you lose half the data because you got to support the negative half below 0. That's what signed and unsigned means. Okay. So got all these data types here. Talked about integers are numbers, but they don't have decimal point numbers. A float has a decimal point. So if you know it's going to need the decimal point, you're going to need to use a float or a double. Double is a bigger float. And then other types. There's data types, or date types, sorry. talking data types already. So there's a date with is just a regular month, day, year format. You can have a date time, which has month, day, year, along with the time, so that you can keep track of when exactly it happened down to the second. Or you can do a timestamp, which is even more granular. It has, I believe, the milliseconds associated with it too. And then I don't know who would use a year type, but so these are the data types you can use, and when you're setting up your database, you're going to want to pick those data types. And we were over here on this example. So this user who set up the person table, they have an int, a varchar, varchars for the other things, which is fine. Our table, for my primary key, I want to use what's called GUID, G-U-U-I-D. Yeah. And I'll pull up the definition of that here. Globally unique identifier, 128-bit text string, represents an ID. The reason I want to use a GUID is because when you use a GUID, you might have seen these before, but it guarantees that it's unique, but you can create the ID from the client or anywhere. So let's go here. Generate an ID. Nope. What did that do? Oh, okay. Here we go. So here's a GUID right there. And so basically, there's a construct in most relational databases which allow the database to generate a sequence for you, so it will keep track of the IDs that you're using, and it will make sure that every time you use that sequence, it gets a new ID. Make sure you don't duplicate the IDs, and it always has a unique thing. And a lot of times they're in sequential order also. Let's see here. Let's go back to the MySQL thing. MySQL sequence. And I want W3 schools. Sorry. There we go. Go back to reference, MySQL. And there should be a sequence reference here. Go back to here. Okay, so let's MySQL sequence. Oh, that's not what I wanted. Wow. All right. I'm gonna go back to Google here. Oh, wait a second. Oh, so you can. Okay, so there. Okay, so MySQL solution is to have auto increment column, which basically means it just counts up by itself, and in this case, it can increment to 622. Yeah, this is really bad design. But what happens is when you insert a record, you have to get the response from the database of what the ID of the record you created was, so that you can keep track of where that record went to. You might create the user and then need to look it right up right away. Well, I don't want to do any of that. I want to already know the ID of the record and generate it and tell the database what that ID is going to be. And it looks like that's probably why MySQL has also ditched that idea. Okay, so we were creating our table here. I'm going to change this from binary 16. I want to look real quick because proj1 is my table, right? And yeah, so I've got the ID column is a varchar 255, which doesn't help us because we don't really, in this example, get to play with our data types, but we do get the right result that we want in the long run. So here we've got ID, data type is varchar, and it's a primary key. That means MySQL is automatically going to index it. We lost our thing. It's going to automatically index it so that it can be searchable and found really quick. The primary key constraint uniquely identifies each record in a table. The primary key must contain unique values and cannot contain null values. A table can have one primary key, only one primary key. The table, now you can join, I believe you can join multiple columns together as a primary key, or yeah, right here. So in this case, you have a constraint pk person, primary key is ID and the last name. In this particular case, they've said, okay, the ID and last name joined together are the primary key. In most use cases, you don't want to do that. There may be some cases down the road as you get better, you do more development and stuff. But yeah, this is a good way to start here. Now, if you want other columns, like say you do want to search by last name or first and last name, but you have an ID as a primary key, but you want your search to be fast when you're doing that, you can add what's called an index on those. To that table so that you can Oh, there it is. You can make it just as fast. It's already searchable and will be quick if you have an index on it. But index will be separate from the primary key. So then I've got name. The rest of the columns are pretty straightforward, just like our example in what we got up here. We got name, street, city, state, zip, country, phone. And I just want to give you an idea of how to create this. I don't want to like architect this exactly the way I would do it from a web development standpoint, because like I showed you earlier, I would split out probably the address, maybe even the phone number. I might have other user data in this table that would relate to the contact, but not exactly that data. But this gives us a good simple example that you can work from. So there we go. Now I created that table, and we can view it using select star from project, whatever we named it, dot contacts, right? Oops, I need the semicolon, and there's nothing in there. We come over here. Let's refresh our database here and go to project, tables, and we have a contacts table. We can view that. There's the data also that it showed that it didn't come up with any results because we don't have any in there. But we do have a database created. We have a table created. We've accomplished this goal of getting the table created. I changed this from binary to a varchar because I want to store the GUID in there. I didn't need to specify not null in the primary key because remember reading MySQL, it cannot contain null value, so that's over. You just don't need to specify it there. Talked about the GUID there. Let's make sure we covered everything in this lesson. Okay, so now I've got an example here of inserting data into our database. So let's do that. I'm not going to run. Okay, I didn't talk about functions. You can learn more about functions as you go. I'm going to take this query out, and I'm going to use that in my thing here. But I'm going to, like I said, I'm not going to use this because it's not going to be binary. But I am going to use UUID, and I will go look that up briefly to just give you an idea of what that does. So functions are tiny programs that can be run by the actual database system software. And let's look here, UID. Oh. So let's go. I don't know if MySQL comes with this by default or not, but let's try this and see how this goes. Okay, I've got it. Let me know if you don't have it. But you might have to go out and install into MySQL additional functions. I'm not sure. Man, I need to use a different browser without the ads. But so here I called select UUID as as meaning naming that column, and gave it a thing. So if I gave it a different name as, like, let's just name it U. So instead of UUID value, it would be named U. There we go. It's named U. The column name is U, and here's the ID. Notice this ID is not this ID, so we're definitely having different IDs here. So let's go back to here, and we're gonna take this record, and I don't want to insert Fred. Fred's already there, but we haven't created Janice yet, and she lives on 45321 Main. I live in Lehigh. Sorry, that's just how it is. We can say New York, and that is in NY. I don't know the zip code. We'll just say 12345, and there you go. So also we're going to update this part because our table name is, our database name is project, not proj1. Okay, so we'll take that in and run it. And now we've got one row. So remember how I did that select a second ago from contacts? Well, now if I select it, there's Janice. She's in there. She's created. And I'm going to show you over here in our other tool that we can do the same thing there, just so that you can see what the point of these terminal, or what the point of this GUI is also. What user should I name her? This is going to be Peter, and he lives on 567, also in New York, next to Janice. So in our client here, we can basically right here, we can run the selected query, initializing, connection ready, statement completed, one row affected. Okay, and then here we'll also do select star from contacts. I want to see if this fails because just run that. Okay, so now we got that. It knows that we're using the project database. Oh, because right here it says localhost project. You can change this to some other database, but it's using that. And we've got Janice and Peter, both in New York, in our table. So that's what we wanted to do here in this lesson, was basically get a place to store users or contact records for our contact list. That's what we're creating here, and we've got one. So set up a database, we created a table, we got MySQL installed, we stored the records, we learned a little SQL syntax, select blah blah blah. We learned more from the W3 School site. We learned where we can find different information to learn more about SQL. Here's some select syntax. You could list the column names out, or you can do star. Star is a wildcard which will give you all the fields in that table. As you start to build a search for your select, maybe you only want Janice rather than getting both Peter and Janice. You can add what's called a where clause. So I've got select star from contacts where, and I'm going to say where ID equals, and we'll take Janice's ID, copy that, put it in a string. If I didn't wrap it with single quotes, then it wouldn't run very good. It would fail. So there we go. We only got the record Janice back when we ran that search. So instead of getting Peter and Janice, we've added a filter using a where clause, and now we just get Janice. And you can learn more about that right here in MySQL where. There's all sorts of other things you can do. Now we're going to be talking a lot about CRUD. CRUD stands for create, read, update, and delete. So I got this going. I'll just write this down for you. So we're gonna make this really big. So we got C, create, R, read, U, update. Oh my gosh. D, delete. Okay. I'll turn this off so this is ugly. Didn't create my hyphens special. Anyways, so in all applications, these are the major things that you're going to want to do and figure out how you're going to want to do. But you're going to want to create meaning in the SQL formats. We created an insert right here, and we wrote the insert, and then we ran it, and that created a record for us. So that's create. Now we read. What is read? Read is we select that record and we get it back from the database. That's a read. Update. We haven't done that yet. We haven't looked at it, but if you want to, we can look at right here. How do we update a column? We have to say update the table name, set column, whatever the column name is, equal to whatever the value for that column is. And then we can do multiple columns by separating with the comma. Let's go ahead and do that. Why not, right? So we got our select Janice right here, right? But we wanted to actually change her name from Janice to something else. So update contacts set name equal to we had Fred, we had Paul. I want somebody new. Let's go with Elon. He's been really popular lately. Where the ID equals that. Elon, he has a different phone number. So we're gonna also do the phone so you can see how to do that. His phone is actually 999-000-1234. So, okay, where the ID equals this. Remember, ID is our unique identifier, so it's never going to be multiple records. If your where clause in an update isn't there or isn't correct, you could wipe out your entire data set and update every single contact with the name Elon and this phone number. That would be catastrophic. Right here, we got one row affected, which means that's good. That's what we wanted. We didn't want to do multiples. Now let's see if Janice is still there. Obviously, you know, and I know, she's not going to be there. It's now Elon. She's got a new phone number. And in fact, we could just basically get rid of this and see. Put a semicolon there. Janice is gone. It's now Elon and Peter. Okay, so we did, from our CRUD, we did update. Now let's do our delete. And sorry, Elon, but we're going to delete you. Oops. Okay, so a delete in SQL is just exactly like the select syntax. Pull that up, come look right here. We've got delete from table name where. Our select is the same. Select column from table name. What you can do, what I always do when I'm doing a delete, let me just copy that line. I always set this up first. Oh my goodness, what is going on? I don't know. Remember, you watch me install this program. I don't know its special keyboard shortcuts, but I set up a select first to make sure that before I run a delete, it's going to delete the right thing and not the wrong thing. So I select it, make sure, and then I'll come and I'll run the delete. Okay, that happened. And if we come run our select again, he's gone. And if we look at this guy, now only Peter exists, which is no bueno. Well, it's great because that's what we told it to do. So let's put Janice back. And let's just make sure she's there. And now we got Janice and Peter. They have the same phone number, different addresses, but that's great. So guys, that's this lesson. I'm gonna get into lesson 3 eventually, which will be backend server programming. That will be a Java application connecting to our database, pulling that data out and creating what's called JSON, which is a packet, a way of structuring the data to send across the web, so that you can, just a representation of the data, basically. Let's see if I can find an example. Here's a good JSON example right there. Name, and then the colon means equals and the value. And then age, colon means equal, so he's 30 years old. He doesn't have a car. Okay, hope you enjoyed this lesson. I'll be back in lesson 3. See ya.